नमस्ते, मैं हूं श्वेता and welcome back to our CTET preparation series. So now today we are going to check about and learn about one more important topic of science pedagogy. So in this topic we'll discuss about the basic strategies or the effective strategies of classroom instructions. So all this is mentioned under the topic called as teaching methods of science. So before we go into understanding what is teaching methods of science and what are the effective strategies that you can have in classroom teaching learning process, we'll first check about how the questions were asked in the previous CTET question papers that we have. So as you can see in the exam trends, it was found that almost in every year question paper of CTET examination, 2 or 3 questions were generally asked from this chapter. So if you see, it's a very frequently asked questions from this. 2 or 3 questions were regularly asked from this topic. So the core topics that this teaching methods of science will cover are basically the observation method that we all know, laboratory method, demonstration method, and also we have problem solving method, heuristic method, and there are also some comparisons between teacher centered learning and student centered learning. So we'll look into all these core topics one by one, and we'll also look into the previous year questions and try to understand how we can solve those and make sure that we have a key takeaway points from each previous year question. So here it's also important that we understand that here in the case of effective strategies of teaching and learning, the teacher has to play a more role here, because as you know, a content should be known by the teacher, that is for sure. But the most important thing also lies with the method in which you teach. The method in which you teach also will give you a way in which you can effectively produce the content in front of the students. So both content as well as the way in which you choose, that is the best strategy in which you choose to teach the content, is also much important. That's the pedagogy part of it. So that will also help the students to learn better. So also it is important that we choose the appropriate way to teach them. It also helps them to learn effectively in the classroom. So it's a major aim out of it, that we are catering to the students. So here, before going into the topic, it's very much important that this part of topic has to be discussed. So there are 2 types of methods here that we know. Like there are paradigms of teaching, 2 paradigms of teaching. As you know, before it was majorly about teacher-centered methods. Now we are slowly shifted towards pupil-centered methods, also called as student-centered learning or child-centered learning. So here, if you see the focus here in teacher-centered methods, so what happens, as you remember, in teacher-centered methods, all we have is a lecture-based method wherein the focus is mostly on telling or informing the information or recalling the information. So the basis of most of this teacher-centered learning or teacher-centered methods here is basically to make sure that rote memorization is done. So basically the focus of this methods will be mostly on rote memorization, because as you know, in this one, teacher is the one who decides how the content should be taught, and she will be the whole focus, and children will be the passive learners in them. So if you see, the child participation in the classroom is limited to only asking questions and answering them. So most of the time this was practiced earlier, and in this case, as we have discussed, students are passive learners and they receive the knowledge. Even this was talked about in critical pedagogy, where they talk about how banking model and banking system, where this is being done. And here in the whole teacher-centered methods, teacher is the center of the class. He is the focus here, if you see. So now we are shifted, some of them shifted towards student-centered learning. So in this, as we have discussed, the center or the main aim is about the student. So much emphasis is given to the needs of the students, their requirements, their interests, their capabilities. So based on all these things, the methods will be crafted for them, crafted to make sure they adapt to them also. So here students are active participants, and their active participants were using laboratory method or their own inquiries method. They will explore their own skills, their own abilities, And it's also makes a classroom flexible, wherein they can modify their own learning according to their own needs. So basically, how child-centered learning can happen, the teacher can either give them a activity, hands-on activity, or a question to solve, or a situation she can give, and based on that students can identify the issue, they can try to solve them, and whatever assumptions they have, they can try to solve them one by one, and they can draw some conclusions based on the observations. So here, as we see, the focus is mostly on the student, and it is also that we emphasize on the needs of the students, their requirements and their interests. So based on this one, we have style centered methods. So now, as we have looking into this, so science teaching can be blended into both of them, teacher centered methods as well as pupil centered methods or student centered methods. But nowadays it is being preferred that student centered learning or child centered learning is more better, because it is good for their deeper understanding and also for their meaningful learning. So also, as we are talking about, let us also check about the teacher centered methods. So in teacher centered methods, we have lecture method, as I was discussing earlier. So in lecture method, what happens? Teacher explains the concepts and reserves time for classroom discussion if the time was possible. Then based on the questions, students try to analyze and respond to teacher's questions. They don't question, teacher questions here and students answer there. So it is actually used, this method is actually useful when you're trying to introduce them certain concepts in a systematic manner. It's not that always some method is good, some method is bad, but some method can be adopted with this method together. So in lecture-based method, all these things can be done. And there is something called as lecture cum demonstration method, wherein you have to make them understand how certain metals react with each other, or certain elements react with each other, where you want to demonstrate and show them how Lee Charter's principle or some other principles work, how pressure works. So all these things can be shown in this one. So basically here what happens is the scientific facts or scientific principles or laws, they are explained through demonstration of an experiment, and through the experiment the theory is explained to them. So by not only by lecture method, lecture cum demonstration is a better way compared to lecture method, because students will observe what is happening and they will have a better understanding on how this scientific facts or scientific laws work in real life. And also it is actually very interesting for them, because it is highly engaging, and also make them easily understand the abstract concepts. And as we know, every method has its own limitations. The major limitation behind this in lecture method is, as the teacher will demonstrate in the classroom using lecture cum demonstration or lecture method, not all students will be able to visibly see clearly the results. The people in the front bench can have a clearer view compared to the people in the back bench. And also there is a risk of limited participation, because not all students will be able to participate in that. So in this one, laboratory skills are not fully developed because the demonstration is done by the teacher, not the student. And the student role here is to merely observe the results. So this is also a good, even lecture cum demonstration improves traditional lectures by connecting theory with practical observation. But for active student participation, we have to move beyond this kind of methods. So now let us see what we have in, what other methods we have by just solving one question one by one. So here we have one previous year question from 2012. The question is as follows. A teacher is conducting a demonstration to motivate students, as we discussed till now, like in lecture cum demonstration method, but the demonstration does not result in expected outcome. Imagine that you have mixed some, we have put an iron in copper sulfate solution, but the copper sulfate solution has not turned pale, or it didn't decolorize. So now you have thought some outcome should come, but that outcome has not come. So the teacher is best advised to do what among the 4 of the options. So we have 4 options here. So what happened here is, teacher is demonstrating some experiment. The experiment didn't go as it was planned. So what is the best advice or best thing for the teacher to do here? So we have 4 options. Find out and explain the cause of failure of demonstration by involving students. Send a note to the science coordinator asking him or her to come to the room. Withhold the demonstration, do it again. Tell the class that the demonstration failed and ask them to help or determine the reason. So if you see here, as we know in lecture cum demonstration method, even if anything goes wrong, if it doesn't happen as it was supposed to happen, the best thing here is to withhold the demonstration and do it again from the first, as this will give you give students the right emphasis that experiment can be done again. But if you see, option number 1 can also be a better one, like find out and explain the cause of failure to demonstration by involving students. Even that can be done, but the most important thing that can be done after you do this one. So the best advice thing to do is first this one, then after the demonstration thing is done, after you explain the concept, then you can do the first one. That is also advisable. But the best advice here is to follow option number 3. After the demonstration, after explaining the concept, you can go and do the option number 1. So here we have this one. So as we talked about, next major important thing here in laboratory work, especially to improve the laboratory skills, that is also one of the way in which you can teach classroom science lessons, right? That is observation and laboratory method. So in observation, what happens? Students will observe using their senses, and they observe and they generate knowledge or construct knowledge based on the observations they have. And as you know, they observe so many things at home, school, so many phenomena they'll observe. So all these things will be helpful for their knowledge construction. Next is laboratory method. As you know, laboratory method is here, the teacher does not become the center as it was discussed in lecture cum demonstration. Here, each group of students will be given tasks to do or experiments to do. So they will be encouraged to do the experiments under proper guidance. So, and they will perform the experiment and write down the observations and come to conclusion. This is laboratory method also. So here the major important thing is they observe, they do the experiment. So they carry out the experiment, they have the autonomy to do it. They record the observations, and based on the observations they try to make the inference. So this knowledge is gained from their own experience. So it will stay as a meaningful experience for a long time. And it's also a hands-on activity which will help them to build deeper understanding and also increase their curiosity levels to ask furthermore questions. Okay. So now we'll go to the next question that we have here. It's from 2012. The question is, which of the following is most suited to the development of scientific skills in students? So just now we have been talking about laboratory work and observation. So based on that, you can answer this question much easier. So which of the following is most suited for developing scientific skills? So scientific skills are observation, as we talked about, inference, classifying, communicating, all those things come under scientific skills. So if you see, if all these scientific skills can be developed from the options, conducting science olympiads. Conducting science olympiads might not be the option here. Then performing laboratory work is the best option we have here. Conducting science quiz can only be better if we can help them recall, but not observe, infer, classify, all those things can't be done. Then we have organizing a field trip. Yes, by organizing field trip, observation skills will be increased, but it will not cater to all the other skills that we have. We have inference also, we have classification. So most of the skills can be met by doing laboratory work. So we can even cancel out this option. So the answer is option 2, performing laboratory work. So next we have to understand about other methods of other strategies of having effective classroom teaching learning. That is which we have been talking about recently also, heuristic and problem solving methods. So in heuristic, as we talked about, it's about self-discovery method. So heuristic comes from the word heurisco. It's from a Greek person. The meaning is to discover, to find out. So the theory was propagated by H.E. Armstrong. He was the person to propagate the theory. So he told that scientific information and facts should be gathered by students by their own discovery, by their own independent thinking. He's like self-learning should be, or self-discovery should be encouraged more for students to understand the scientific laws and scientific principles. Okay. Then next comes the problem solving method. So as we discussed in science subject, we must think of developing scientific process skills, which we were discussing in the previous question. So scientific process skills are observe, measure, classify, process, process information, interpret the problem solving, analyze, synthesize, and formulate conclusions. So these are the process skills. So you can remember: observe, measure, classify, process information, interpret, think on solving problems, analyze, synthesize, and formulate conclusions. So these are the scientific process skills. So problem solving method will help them to encourage to develop all these scientific process skills. So let us understand what are the steps in the problem solving process. Okay, as we have discussed earlier in the earlier videos also about how problem solving is important and all those skills have to be developed in students. So first and foremost thing in problem solving is to identify the problem and clearly state the problem. Then gather the information that we have or collect relevant facts and data regarding the problem. Then after collecting the relevant facts and details, we have to formulate a hypothesis. So hypothesis, it's like you can understand this as a cause and effect. Like for example, if we put if and then kind of statements can be formulated in case of hypothesis. So these it's nothing but it's also called as a educated guess, that you know for sure this will happen. Or you can make a statement like how a lawyer will tell that this was done by this person, or the crime was committed by this person based on the facts that are pointing towards them but without proving them. The initial statements the lawyer makes in the court or initial judgments you have. So those kinds of things are called as hypothesis. A basic analogy was given to you, but see. Next is testing the hypothesis, testing your assumption regarding why the problem might have happened. Then you test your hypothesis, then you will analyze the results based on your observation interpretation. Then after observation, you draw your analysis. After doing analysis, you draw your conclusions or inference based on the evidence that you have secured. Then after drawing conclusions, you communicate the findings. The next major important thing in process skills is communication of your findings. The next is how you reflect upon the learning that was done and how you plan to use that learning in the next phase. So these are the steps of problem solving process. So majorly these kind of strategies of teaching and learning, like heuristic method, problem solving method, all of this will help in increasing the creativity of the students, help them to think critically, explore the nature around them independently, and make sure that the learning lasts longer and more meaningful than what was taught in lecture method. So now let us move on to the next question we have here. It is from 2015. So the question is as follows: which one among the following situations gives the learner the best opportunity to discover knowledge? It is about discovering knowledge. Okay, so here we have 4 options. I have highlighted the word for you to understand what is the major one we have to have focus on. So the options are as follows: students being instructed through team teaching on materials of daily use. It's instructed. You just remember the words that are there in each option. Students undergoing an elaborate and detailed sessions of programmed instruction on the topic components of food. See here, they are undergoing detailed session about the topics. Okay. Students being first shown the demonstration of Archimedes principle followed by detailed explanation. So here they are using lecture cum demonstration method, if you have seen. So first demonstration is done, then they are explaining about the concept to them. Okay, and here lecture method is going on, and here also lecture method is going on. Team teaching is a process where 2 or more teachers come and teach in a class. Example, if you take science concepts, there are certain maths things that are involved in them. So yes, maths teacher can come and teach first regarding that particular concept, and science teacher can take over from there. So this can happen in the classroom also. So the 4th option is students labeling the given materials as conductors and non-conductors by placing them in a self-assembled closed electric circuit. So if you see the question, it's about how they can discover the knowledge, means self-discovery, heuristic method. So in the 4 options that we have, here in every option, students were being instructed or they were demonstrated. But in the 4th option, if you see, they themselves were analyzing and discovering which were conductors and which were non-conductors by placing in a self-assembled closed electric circuit. Means they were themselves discovering if the current was passing through, it was conductor, it was not passing through, it was non-conductor. So they were observing, analyzing, they were classifying also. So all these are part of heuristic method. The science process skills were developed here. So they were discovering the knowledge by themselves. So fourth option is the right option we have. So let us proceed to next question in our hand. The next question is from February 2016. The question is, teacher wants to use inquiry approach to teach shadow formation to her learners. Which of the following strategies would be most suitable for teaching learning of this concept? Okay, so teacher wants to use the inquiry approach for teaching what? Teaching shadow formations. So which of the following strategies? Here are 4 options that we are given. We have to choose which is the best suitable one for inquiry approach. Let us see the options one by one. Show a PowerPoint presentation on formation of shadows. It's like again a demonstration method but with a digital component in it. Let the learners observe around them and try different materials for the formation of shadows. We'll go to the next option. Ask the learners to read relevant text from textbook. This cannot be because we are just telling them to read about it, but not giving them any experience. Inquiry is about going around asking, trying to understand things. So it is different from what is being given here. Demonstrate the formation of shadows by objects to learners. It is demonstration again, not an inquiry based approach. So we can cancel out all the 3 options. So remaining options, let the learners observe around them and try different materials for the formation of shadows. This is about inquiry is nothing but you give a certain situation to them. They just go on checking hypothesis whether this will happen or not, how each of the object or each of the thing interact with each other, and they try to draw conclusions by themselves. This is one of the method of inquiry approach. So let us proceed to next question that we have. The question is from 2014. So the question is, the following steps, not in proper sequence, are generally recommended to be followed in scientific method. So these are the steps 1 to 5. These are not in a correct sequence. We have to choose the option which denotes the correct sequence. Okay. So as we discuss in problem solving also, any scientific method follows certain sequence. So if you see, even in case of problem solving or scientific method, we discuss that we have to first identify the problem. So this comes your first one, right? Then after identifying the problem, we have to formulate the hypothesis, right? Then after formulation of hypothesis, we have to test the hypothesis, right? We have to collect data. Then after collecting data, relevant things, we have to test the hypothesis. Then after that, we have to draw conclusions based on the testing of hypothesis. So now we will check which option goes well with that. So if we see, C is the first one. So C goes in 3 and 4. And next comes formulation of hypothesis, the second one. So then we have this one. So we can tick the option 4. So as we have discussed initially also, the steps in scientific process of problem solving, you can follow those steps and answer this one. So even this question was asked, and again we have a 2016 question. Which of the following correctly describes scientific hypothesis? So here we have to understand the definition of hypothesis. As I have told, hypothesis is an assumption that you have, which you test and then confirm based on the results you have to generate a conclusion. So it's a tentative explanation based on what is already known. So this is your answer. Okay, it is not a concise statement about a phenomena. It is not a concise statement. It's a tentative explanation or a tentative or educational guess, we can say. Okay, so this is the answer. So next we have one more question from 2015. Teacher places a lighted candle on the table in the classroom. He later covers it with a jar. So A, B, C are the observations or statements given. So the options here are 4 options on the right side. So let us see the statements. The candle stops burning after some time. Yeah, that will happen if you cover it with a jar. Air is required for keeping the candle burning. Yes. Oxygen is required for keeping the candle burning. Yes. So here we have to understand which are inference and which is observation. So observation is what you see. Inference is what you conclude based on your observation. So let us first check which is observation here. Candle stops burning after some time. That is observation. That is specifically observation. So air is required for keeping the candle burning. Oxygen is required for keeping the candle burning is your inference. So let us check if options are there. So all statement inference is wrong. All statements observations is also wrong, because as we have already talked about this one, only statement 1 is observation. Yes, this is true. Statement 1 and 2 are observation. No, both are not observation, because air is required to keep the candle burning is a kind of conclusion or inference you might make out of it. And then you specifically go to understand oxygen is required to keep the candle burning. So remember, observation is what you see or what you can measure, and inference is a conclusion or explanation that you draw based on the observation that you have or your prior knowledge. So we'll go to the next question that we have is from 2016. The question is as a teacher gives an iron nail, a coal piece and an aluminium wire and a pencil lead to her students and asks them to identify the materials that can be beaten into thin sheets. Okay. She further asks them to record their findings. So teacher has given them a task. She has given them materials like iron nail, coal piece, aluminium wire and pencil lead. Now she has asked to identify students which among the following can be beaten into thin sheets. So which of the following process skills are being assessed through this task? Okay. So we know we have talked about the science process skills. So now we have to identify by this experiment which science process skills will be developed in them. So as we know, she told to identify first, right? Identify which can be beaten into thin sheets. Means we have to classify metals that can be beaten into thin sheets, which cannot be beaten into thin sheets. That's why we are classifying first. Then first we'll observe which can be beaten, which cannot be beaten. That is first observation is going on. Then after observing, you have an inference. Then you conclude. So observing, inference, then you communicate your findings, right? So we'll find out which are there. So classifying, communicating, observing, yes, is happening. First we'll observe which can be beaten on thin sheets or not, or you can remember from a prior knowledge. Observation is also that. If you remember from a previous thing, we see or measure. Inference is something you remember from prior knowledge. So we'll observe first which can be beaten on thin sheets or because it's activity. Then based on that observation, we have an inference. Then we classify which can be beaten on thin sheets and which cannot be. Then we communicate our results. So here we don't predict anything here. Predicting, classifying, questioning. We are not questioning here. So this can be also avoided. And even this option cannot be the correct one. So the first option is the correct one. Classifying, communicating and observing. So let us proceed to the next question we have. So class 7 teacher plans a task for students of classifying 25 plants. Which of the following strategies best support inquiry teaching? So she has given 25 plants and asked which of the following strategies best support inquiry teaching. So there are many questions asked about inquiry teaching if you have just observed. So the options here, they are here. So let us see options one by one. Teacher explains scientific classification system and demonstrate it. Teacher gives rules for classification and asks students to classify the plants. Teacher allows each student to classify in their own way and discuss them. Teacher took students on a field tour to show the plants. So which is better for having inquiry teaching? You have to remember the question, inquiry teaching. You have to read the question again. So here, teacher has to allow students to classify in their own way and discuss them. So this is the right option. If you see other, teacher explains scientific classification will not will not proceed to any inquiry based learning because teacher is explaining. Teacher gives rules for classification means half of the work is done, so it is not inquiry because most of the thing is already done. Teacher took students on a field tour to show the plants. That is field trip but not an inquiry kind of lesson, inquiry kind of method. So option 3 is the right option. So then we have one more question. Which of the following does not match with the equitable use of ICT in science pedagogy? So even the use of pedagogy is being talked about in, use of ICT is being talked about in science pedagogy. Let us check the 4 options we have at our hand. Encourage the use of free and open source software for creating digital teaching learning environment like the virtual labs. Ensuring the availability of appropriate multimedia software in English and other languages. Encouraging teachers to be users rather than developers of technology. ensuring digital access for all sections of society. So if you check the question, they have asked not the match for equitable use of ICT. Equitable use is where everyone can have the access to ICT, where everyone can use ICT for their teaching and learning. So you remember the question, it is not a match. So first one is actually encouraging teachers to use ICT for their own building of virtual labs or using the virtual labs to teach students. Ensuring the availability of appropriate multiple. So availability is already mentioned. So this cannot be the answer. Encouraging students to be users rather than developers of technology is restricting the equitable use of ICT. So this is wrong and this is also right. So based on the question, we have to pick up the wrong statement. So wrong statement is 3. So the correct option is also 3. Okay, so let us proceed to the next question. Is from 2015. The question is, how could learning be made more meaningful for students of class 7 by the teacher while teaching the topic save water? So it is about asking how we can make the learning more meaningful. So we have 4 options here on how we can make the learning of the topic save water more meaningful. The 4 options are as asking students to interview people in their colony about water consumption and carry out water audit, conducting a quiz competition, asking students to design posters, asking us to write an essay. So all these things will help them understand why water is important. But by doing the first one, conducting a water audit, will make them understand the current situation. It will lead to deeper learning also. So the first option is the correct option. So next we have one more question from NCF 2005. NCF 2005 recommends that teachers should engage in action research. So this is one more aspect in action research. So action is nothing but it can be understood like a research carried out in a classroom, specific classroom for specific problem. And the results done by action research cannot be generalized. Imagine in your class if certain students are not able to perform well, or certain batch of students, when you teach them in English, were not able to understand or comprehend. So you conduct the action research based on that specific problem. So those generalizations cannot be generalized to whole population. It can be just done for that specific class, specific classroom. Let us check which of the following aspects is not integral in conducting action research. So first option is not. Again, you have to remember the question is not. It is conducted by practitioners themselves rather than professional researchers. Yes, the practitioners here are nothing but the teachers. So this option is wrong, but according to action, this is the correct answer. So if you see, action research tells that teachers have to conduct this, but not the professional researchers. So next is, its purpose is to develop new educational theory related to teaching and learning. So actually, if you see, by conducting action research, we will not generate any educational theory, but we will try to find out solution to a problem. That's all. The results of action research may not be always generalized. This is what I was speaking about. You can't generalize the results of the research. It is a planned process involving identification of a problem faced by the practitioner. So if you see, all the 3 options are correct, but only this one is wrong. So this is your right answer for this specific question. So whenever like these questions are asked, please see if it is not question or it doesn't have a not in the question. It is very much important. Okay, then one more question we have. Which of the following tool is learner-centered assessment? As we talked about, this is learner-centered assessment. Portfolio is the learner-centered assessment. Concept map is a learner-centered assessment. Journal writing is only paper pencil test is not a learner-centered assessment. So the answer we have is A, B, D. That is the third option. So we have again one more question with us. Given below are the steps to test the presence of protein in a food item. These steps are not in correct sequence. So it's the same part of again our scientific process skills, or a problem solving or scientific method that we have to follow. So if you see, take a small quantity of food item in a test tube, add 10 drops of water to shake it. Make a paste or powder of the water of the food to be tested. Add 10 drops of caustic soda solution to the test tube and shake well. Add 2 drops of copper sulfate to it. So it's a scientific method and we have to arrange it in the steps. So if you see, first we have to make the paste or powder of the food to be tested. That is the major issue, right? We have to first make sure this is done, because we are testing the food one here. Then next, after we make a paste of it, we'll take a small quantity in a test tube and we'll put the chemicals that are required to be put. So that is the second one. So after that, after putting that, we can add 2 drops of copper sulfate, then 10 drops of caustic soda. This is nothing but testing of proteins. If you have seen this, the same thing in our food chapter in the morning, we have talked about the testing of how we can test the presence of proteins. It's the same steps that are being followed, but here it is used to understand the scientific process of this one. So based on this one, the answer is 2, right? So there is one more thing in this teaching methods of science, that is ethics, that we have to follow. So most boards of education have banned the dissection of animals because there is need to sensitize students to prevention of cruelty to animals. So this is a correct option. As you have known, most of things are banned now. There is no dissection of animals to be done or any organisms to be done in the classroom. So now we have one more question. The technique of classroom questioning is teaching of science can be more effectively used. Yeah, classroom questioning can be more effectively used to ensure levels of learning, develop problem solving skills, maintain discipline in the classroom, promoting creativity and innovativeness. So in the case which is more effectively used for. So in all these things, if we see questioning is done, you can eliminate the third option, maintain discipline in the classroom. That is not the major purpose at all for questioning. So you can see the remaining 3 options. Ensuring levels of learning, that is not the purpose because it is not more effectively used. Promoting creativity and innovativeness, that can be a result of it but not the important purpose. So here if we see, the answer is developing problem solving skill. So whenever a teacher gives a problem or situation which has to be solved, then classroom questioning can be a very much important thing in using the problem solving method in the classroom. So by using this problem solving method in the classroom, which requires questioning, which stimulates thinking in students, how to solve this problem, all these things can be done. Okay, so now by this we come to the end of the teaching of all the questions. So let us summarize what we have taught till now. As we have discussed, there is shift happening from teacher-centered learning to learner-centered learning. Or student-centered learning, which talks about how learning can be more flexible, where students can become active participants. Then in this one, we discussed the core methods of teaching science, that is lecture cum demonstration, observation and laboratory, and discovery learning, problem solving skills, scientific method, science process skills were discussed, which were observing, classifying, hypothesizing, and communicating, interpreting. So all these were discussed. So you can also make a list of all the science process skills because it's the most asked question, and also you can think about many other different teaching methods of science which will be covered later on also, wherein inquiry based method was asked a lot. So you can see this one. So by this we come to the end of discussing the topic of teaching methods of science. So thank you so much, and we'll see you again in the next video. Thank you.